everyone. Thank you for joining us today for SoftServe live webinar, Voice Enabled Healthcare. Please send your questions that you might have during the webinar to our webinar email address, webinar@softserveinc.com, or here in live chat. We will gladly answer them during our Q&A session at the end of the webinar. And now let me introduce our speakers, Igor Vasyutin and Yuri Milovanov.
Hi, my name is Igor Vasyutin. I'm Solution Service Product Manager at SoftServe with more than 15 years experience in IT industry, and I'm part of the healthcare group at SoftServe. We consult, design, and develop solutions like patient engagement and interoperability, analytics, and machine learning.
Yeah, and my name is Yuri Milovanov. I'm a data science practice lead for SoftServe, where I'm responsible for helping our clients adopt various cutting-edge advanced analytic technologies such as data mining, AI, and machine learning in general.
Let me summarize some healthcare trends that is mostly specific for US market, but also can be applicable for European markets. So among those, very powerful trend to shifting the reimbursement model for providers from fee-for-service to fee-for-quality or value. And that has a tremendous impact on all players in the healthcare ecosystem. Other than that, the patient becomes in the center of the healthcare ecosystem. He has more decisions on how and where to get the healthcare services, and that means growing demand on the cost and the quality transparency. So as overall in our days, digital transformation is in all industries. Healthcare is not an exclusion from that rule, and so consumers demands digital channels to communication with healthcare organizations. And growing cost on national spendings for the healthcare also driving the preventive care actions, thinking about changing the popularization of the lifestyles, which is called in summary population health management. And cutting-edge technologies like data analytics, artificial intelligence, virtual reality, and wearables or body devices are all becoming more and more adopted in healthcare industry. If you take a look at the directions, we would like to talk about consumer engagement, provider efficiency improvement, and population health management. All of them has real good use cases for artificial intelligence applicabilities. And talking about healthcare consumers, we can imagine voice assistant smart device or bot that can understand natural language and can respond in natural language. That gives us capability on basis of consumer 360 data we have to interact with a patient or consumer. And talking about consumers, we can divide them into groups like healthy populations and chronic conditions group of people and acute illness populations. So obviously the goal for all these groups is different, but we can still apply the similar scenarios for communication with those people. So for example, education, and starting from education about changing the lifestyle to be more healthy, more active, more healthy food, and managing the chronic conditions like how important is that to stay on regimen, to sleep well, to take medication in time. So all these education activities becomes important in the overall managing the conditions. For acute care, we can indicate the details about specific disease or importance of adherence to medications, to therapy regimen, right? So for fastest possible recovery, right? So in talking about engagement and assistance, we can notify patient about the oncoming and visits to provider, the needs to refill some specific medications, and even cases like, did you have a medications today in the morning? Do you feel well? Any side effects you have? And the responses back from patients is collected in Consumer 360 as real-time data, and that's called monitoring of the health conditions that later can impact the intervention of the provider for some specific cases. So as you see, having the smart machine that can understand and process the natural languages can be applicable to a lot of use cases for engaging patient and engaging him or her to self-care. Talking about providers, nowadays they are very overwhelmed with the documentations. There are a lot of regulations and initiatives over the last couple of years that requires them to report and collect data in specific format. But anyway, we're still in a state when recorded information is a low quality. So for them, we suggest assistants that can process the natural language and can document, can convert the natural speech language into the text that can be populated in specific areas of EHR system. Voice biometrics, or its identification of the person, as in the healthcare domain, we have a lot of HIPAA regulations, so person identification is important. One of the technologies allow us to do that just by recognizing the voice. So documentation of the patient information, which is natural and less time consuming, is very important for providers. So in overall picture, looks like we have two sides of the ecosystems. There is more players, obviously, but for simplicity, we can just touch this and see a lot of values. So on the right side, we already talked about consumers and all information we collect in real time from patients, including the answers to the questions like side effects, pain levels, specific conditions, and also including devices like wearables and mobile phones that can collect information from patients in forms of vital signs and aggregate them in Consumer 360 database. On top of that, we can have a machine learning algorithm that identifies the patterns in the huge amount of data sets and can alert or assist a provider to take some preventive actions or make a clinical interventions in some specific cases. So, for example, suggestions like the seasonal free flu shots or preventive vaccinations is required for a specific group of people, or patient Mary, which is 2 weeks after the surgery, needs a follow-up call and follow-up meetings, right? So that's for simplicity, but very useful use cases. The machine learning algorithm can also, and that's all important, that all can be communicated with communication with provider can be in natural language, and some specific item like to-do list for today. So I have prescription refill to sign today, right? Or please call to pharmacist and resolve the issue with prior authorizations of some prescriptions, right? So cases like that will simplify the day. Will suggest providers what are the next items we can do for increasing the health of population I'm responsible for. So, and that's mechanism of man in the middle smart machine that on one hand collect and educate and engage patient for self-care. On the other hand, keep provider informed about some specific cases that requires maybe even clinical intervention. And in overall, in summary, it impacts positively on the health of population, including chronic conditions and acute care populations. So let me then give a floor to Yuri.
Yes, thanks, Igor. That was really insightful. So now let's look into the voice-enabled healthcare domain from the technology perspective and see what are the nowadays capabilities, challenges, and limitations of this market. So technically speaking, this use case addresses two different AI-related problems. The first one is speech recognition, which aims to transform spoken language into text, and the second one is natural language understanding that tries to derive meaningful knowledge from the text. Those AI industry is the one that actually drives all the explosion in this field. So what are the main factors that made us think that this is even feasible, right? So first of all, it's worth mentioning that mimicking human cognitive function is an extremely challenging task, primarily because we still do not know how it works in our brain, which makes it really difficult for traditional rule-based software engineering techniques to tackle this problem. Machine learning directly addresses this issue by providing a way to learn a solution directly from the data instead of hand coding it. Although machine learning has been around for decades, there were few crucial pieces that used to be missing for successfully applying these technologies. So first one is data availability. It's a necessary ingredient that hasn't been available for us until now. Surprisingly, more than 90% of the digital data in the world today has been created in the past 2 years alone. Now that we can collect or process and access such a huge amount of data, we can also leverage it by using it to train complex machine learning models and uncover really deep insights into the data and the business. Second piece is powerful algorithms inspired by cognitive and neuroscience. Now, modern machine learning algorithms and deep learning networks in particular help us achieve near human level of accuracy in many different AI problems, including speech recognition and natural language processing. And the last piece is computational power. Thanks to big data technologies and GPU accelerated computing, now we are able to scale out our deep learning workloads and apply them against really large-scale data sets. Here is a good example of the impact that these three factors made. This is a chart that illustrates what was happening in speech recognition community over the last few years. So you can see that since the 90s, there has been a steady increase in performance of decreasing the speech recognition error. And then in the next 10 years, basically nothing was happening. Speech recognition was working, but it wasn't good enough even for simple use cases. And since the introduction of deep learning back in 2010, you can clearly see a huge performance progress of these systems. And by now, state-of-the-art solutions are able to even outperform humans in some specific or limited speech recognition tasks. Of course, there are still some challenges. Just try to speak to your Siri or Alexa and you will easily recognize them, right? But I think that in the next few years, speech recognition will be completely solved. Now let's see how mature are these technologies using so-called diffusion of innovation model. This model illustrates a typical technology life cycle based on its adoption by different market segments. It states that the technology adoption begins with a tiny number of visionaries or innovators that lavish great time, energy, and creativity on developing new ideas. Once the benefit starts to become apparent, early adopters sort of leap in. Those usually try to get a competitive advantage by adopting new technologies and they have time and money to invest into it. Then, assuming the technology leaves some sort of chasm, it may eventually reach the early majority audience, Those are usually pragmatists, comfortable with progressive ideas, but they won't act without solid proof of benefits. Once the technology reaches the early majority, it's usually considered to be mature. Next is the late majority group, which is actually more like a skeptical group that adopts new technology just after the average market player. They are conservative pragmatists who hate risk, and they are generally uncomfortable with new ideas. And the last group in this chain is laggards that actually hold out to the very end. They may see some sort of a high risk in adopting a particular technology or product. Based on the recent market research, big data technologies have already reached late majority market and are not longer considered to be innovative. And on the other hand, machine learning has just reached the early majority and is already adopted by many big enterprise companies. And finally, I would like to show you a success story that is based on the project that we delivered to one of the biggest EHR providers in Central Europe. And the goal of this project was to automate and optimize various EHR and clinical routines by providing a speech-driven digital healthcare experience to both patients and physicians, leveraging various state-of-the-art machine learning and AI technologies. And actually, the biggest challenge of this project was to design support for multi-language speech recognition and natural language processing, and German in particular. So the use case that we started with was to automate discharge summary generation. And the user story here is the following. A physician provides all the details of the episode for a particular patient by dictating it to the mobile HR assistant app and then sends the recording to the cloud backend service. Here is actually where all the magic is happening. Backend process gets the textual representation of the recording, extract all the clinical and medical details that should be ingested into HR system and then included into discharge summary. And once the data is ingested, a nurse assistant or other clinical expert receives a notification to review the data, correct the mistakes, and add any additional information or details if they are required. And finally, a physician makes the final review and approves the report. And here is an illustration of what is going on under the hood. So once again, it's a two-step process that starts with a machine learning-based speech-to-text transformation. This actually can be done using various cloud-based services from Google, Microsoft, Amazon, or IBM that provide large-scale enterprise-level speech recognition capabilities. But the biggest problem with those solutions is that they are not tuned to a particular business domain. They're mostly focused on a general lexicon. Alternatively, many open source solutions are available on the market, but their application requires massive amount of training data and deep expertise in applying those techniques. In this particular project, we decided to develop a custom machine learning solution using publicly available sources of training data, augmented with manually collected medical and clinical audio recordings. So the next step aims to parse this textual representation to detect and extract all the required structured entities, such as medications, diagnosis, vital signs, clinical procedures, persons, organizations, etc., along with corresponding kind of support facts such as localizations, dosages, time frames, so on and so forth. So some of these data points can be extracted using some sort of a dictionary-based approach, leveraging various publicly available medical databases and ontologies such as ICD-10, UMLS, and many others. And for those that cannot be listed as a dictionary or for out-of-dictionary data points, we had to apply machine learning techniques that are able to recognize language-specific patterns that lead to a particular entity type. Then the result is compiled into JSON format and transferred to the EHR system. So yeah, that is it. Thank you very much for your time and attention. Now I think we can move to the Q&A session.
Yes, so thank you, Igor and Yuri, for such an insightful presentation. So let me have a moment and check our email address, webinar@softserveinc.com, for any questions. You can also submit your questions here in live chat. Okay, so I can see we have a couple of questions coming into our email address. So here is the first one. Do you see any example of voice AI in pharma industry?
Oh, well, that's probably a question to me. So yes, that's a good question. So I can remember even the real case, and one of the let's say startup biopharmacy was approving the medical equipment in the FDA, and it was a second round of approval. They were thinking how to add value to the device with an immobilizer, so patient should breathe as antibiotics to the lung and kill the bacteria inside of the lung. So it was not painful, but a long-running therapy. So half a year you should stay on this therapy and clean the device and be able to do it in time, to change the liquids inside. So all this is time consuming and pretty the therapy is efficient, but the problem was that the patient was not following always this therapy. And it was idea, how can we empower the device itself with a device like assistant device that can speak natural language, can educate patients. So how to clean the device, what's the issues with breathing, what are possible side effects. And so and the education becomes a part of the tool, right? It's kind of supplemental for free skill plus actual device that was delivered with the immobilizer itself to the patient and assisted him in case of the troubles, and also could connect to the real person if the issue is some more serious and patient requires that. So pharmacy can empower the medications and the tools, equipment with artificial voice-enabled technologies. Thank you.
Thank you, Igor. And I think we have another question, more technical one for Yuri. So Yura, are there any open source frameworks or solutions that can be leveraged for these use cases? I guess for the ones that you've mentioned in your presentation.
Yeah, so that is actually a great question. Since the AI industry in general is driven by a scientific community, which is actually one of the best examples of the open source, right? There are quite a few different solutions and frameworks that can address some of the issues for this use case. Unfortunately, there is no end-to-end solution, open source solution to this problem. So from speech recognition perspective, there is a project that is called Sphinx from Carnegie Mellon University, which actually allows you to use either a set of pre-trained models, most of them trained using really cutting-edge and state-of-the-art machine learning techniques, or you can also train your own custom model if you have enough of training data. And from text mining perspective, there is a project which address a lot of challenges in issues for this use case. There's a project called Apache CTAKES. It's a natural language processing system for generally information extraction from EHR. So it provides end-to-end NLP pipelines. It supports different languages. It natively supports various dictionaries and ontologies. It's able to identify drugs, diseases, symptoms, and many different types of entities. It's actually a production-ready framework. It's a top-level Apache Foundation project written in Java 8.
Thank you, Yura.
This will help.
Thank you. So looks like we don't have any other questions. So I would like to thank again to Yura and Ihor, and thank you everyone for joining us today.